Hi, everyone. Welcome to our July Meetup event. I'm Patricia Schuster, one of the co-organizers, together with Sean Law and Ben Zylan, who's in the back. Today is our lightning talk event, which everyone has been looking forward. We have 4 speakers today who will each share a short presentation on their work or something interesting in the field of data science. So we just have a few things to go through first. First, we always like to acknowledge our sponsors. So NUM-focused sponsors our Meetup group participation. TD Ameritrade provides the space for us to meet in. And Midas, we have some Midas representatives here today. And Midas sponsors our dinner for these events. If you're affiliated with Midas, you want to give a little wave? Great, lots of Midas people here today. We're always looking for feedback. So this is our Twitter and our email address if you want to provide feedback there, or just directly to one of the organizers throughout the evening. So a few points. Emergency exits, we have a staircase here. Please don't use the elevators in case of emergency. As I mentioned, provide feedback to us directly or through any of our accounts. And also, this is a borrowed space, so please clean up after yourself before you leave. So for Q&A, just a few guidelines. So unless your question is quick, hold it until the end of the presentation. That's especially important today since we have 4 presentations. Please phrase your question in the form of a question and keep your questions to 30 seconds or less. Avoid long statements and monologues. And also remember that there will be open time for discussions at the end of the entire event. You can come up and find whichever speaker you want to talk to directly. OK, now I'll read our code of conduct. PyData is dedicated to providing a harassment-free meeting experience for everyone, regardless of gender, sexual orientation, gender identity and expression, disability, physical appearance, body size, race, religion, or level of experience. We do not tolerate harassment of meeting participants in any form. All communication should be appropriate for a professional audience, including people of many different backgrounds and levels of experience. Sexual language and imagery is not appropriate for any of our meetup events. Be kind to others. Do not insult or put down other attendees. Behave professionally. Remember that harassment and sexist, racist, or exclusionary jokes are not appropriate for PyData. Attendees violating these rules may be asked to leave the meetup at the sole discretion of the meetup organizers. Thank you all for helping make this a welcoming and friendly event for all. So we like to do a quick icebreaker so that you can meet the people around you. The topic this month comes from Sean, and it is, which do you like better, water parks or theme parks? So come to a decision.
I think it depends on the weather.
Depends on the weather.
Yeah, if it's cold out, then I'm not sure have you ever been to Cedar Point?
That was a good, OK. So can we get hands for theme park and water park? And it depends on the weather? I like that answer. OK, great. OK, so we always do this month in data science. And this time we want to mention that there was recently an international summer school on deep learning. And it was hosted by 2 people who are locals to Ann Arbor. There were 3 hosts.
Speakers.
Oh, I'm sorry. They were invited speakers, 2 of whom were local people from Ann Arbor, Dan and Alexander. And then also, oh. Hello. And also Sebastian, you might recognize that name because he's been one of our speakers in the past. And was it a good event? Did you enjoy it? OK, excellent. Good. Our next event will be August 14th. Our speaker is Jacqueline Nolis, and her topic will be when data science projects fail. I think we can all relate to that. So she will have the answer to rescue us for when our projects fail.
It'll be a joint event with the Ann Arbor R user group as well.
Oh, excellent. Joint event with the R user group. OK, so now we have some time for community announcements. If any of you want to mention an event that's coming up, or if you're looking for someone to join your group, you have a job opening, or if you're new on the job market and you want to maybe mention that to everyone, does anyone have anything they want to share? OK.
Hi. I work on the research.
What's your name?
My name is Brian Lester. I work on the research and data science team at Interactions, which is here in Ann Arbor. We're looking for someone with experience in NLP. We generally use a lot of Python and deep learning, but general experience or knowledge of data science, that kind of stuff's also good.
Great.
I have one. So my name is Kara Everett. I work for a language learning company. It's a tech company in Farmington Hills. So we're looking for a data scientist. So if any of you are interested, please see me. Or you can check out our website. So it's mangolanguages.com.
Excellent. Clayton?
My name's Clayton. I'm the first data scientist at Everactive, which is a startup here in town. We do like industrial sensor monitoring and detection, like automated detection of equipment failure. I'm looking for a second data scientist to help me build out the team, do a lot more hiring in the future, and also make sort of high-level decisions about how we work and what tools we use and things like that. We're a Python and R shop, Git, SQL, all that kind of stuff, so come chat with me if that sounds interesting.
Very nice.
Yeah, my name is Fadl Alfa. I'm from the Department of Computational Medicine and Bioinformatics in the University of Michigan. We are looking to hire a software engineer who has experience in JavaScript and Google Cloud. So to do analyzing for single cell RNA.
Great.
My name is Kristen Bergard. I'm with the Michigan Institute for Data Science. And if you have job openings, and you want to just, grab my card or whatever, we're happy to put it on our website and send it out to students.
Excellent. Trisha?
And I'll just make a quick introduction. I'm Trish Fountain. I work with Kristen at the Michigan Institute for Data Science. This is not a job announcement, but I just want to put a feeler out. I know that this has come up in past meetings. We will be forming a mentoring network and a way for students to partner with industry professionals in data science. So if that's something that you're interested in being a part of, I also have cards I'd like to connect with you.
Yes.
I'm already compiling a list for that. So if you want to talk to either one of us.
Thank you, Sean.
On either side of the mentorship, if you want to be a mentor or if you're a student who's looking for a mentor, talk to us. Any others? Paige.
Hi, I'm Paige. I just finished my PhD, like climate modeling and ocean atmosphere interaction. So I don't know a whole lot about the data science world specifically, but I'm very used to working with Python and data in general. So I'm kind of here to learn about data science and kind of scope out various job opportunities.
Excellent. Wow, lots of job openings. It's great news. Okay. All right, so now I'm going to introduce our 4 speakers now at the beginning. Our first speaker is Brittani Wilson, who will be speaking on wrapping up a master's in data science. Our second speaker is Ashley Payne on data in earth science and atmospheric rivers. Our third speaker is Rose Putler, the ABCs of career confidence. And our fourth speaker is Laura Burdick, lessons from multilingual data. So let's welcome all of these speakers.
Okay, so I'm working on a master's in data science. My bachelor's is in business administration. Having a conversation with a friend, she was like, you should diversify. So it's kind of how I ended up here. I used a multi-criterion decision-making model to kind of, is this what I want to do with my life? Should I do something else? Decision-making process. Okay, so I guess I wanted to learn more about programming. I worked with C++ in high school, which is kind of like, maybe I should refresh on that a little bit more because I haven't been really working with it too much. And then I guess the decision to go for a master's in data science or just a master's in general is access to resources. So access to teachers, but also online libraries. You can get a lot of good books that can teach you more outside of class. So I guess I'm going to do a quick overview of projects. So if anyone's interested in machine learning, this is all done in R. So I did a few different, so there's some classifiers on here. So there's a reinforcement learning example, and this is all, you can just basically plug it in for the most part if you know how to program in R. Let's see, so then there are some data engineering classes involved with it. I was considering doing the specialization, but it just didn't fit in with my time frame. But I'm still taking, so I'm going to take a data wrangling class coming up, and then still staying on the data science track. I'm doing, my next course is going to be in deep learning, and then I have my practicums coming up. So I'll be done in April. It took me basically, so I think I started January 2018. I also work as a field researcher for UMich. My schedule is kind of flexible, but 35 hours a week, mixing it in with this kind of slowed me down a bit, but I don't know. Anyways, I enjoy both things. Let's see, so where I am now is essentially I'm deciding on, okay, so maybe I should talk about, so this is some of the stuff I've done with Hadoop. This is a MapReduce project, a basic recommender system. I'll show my website if anyone wants to check it out a little bit more later. I'll show you the link and how to get in contact with me. So I work with Vagrant and Mbari. So building out nodes, MySQL connector, Anaconda installed onto these, and then deploying them. I don't know. So there's some projects with HBase, and then we made an inverted index with Jupyter Notebook and PySpark, and then working with Sandbox. I need to build out my Git. I haven't really been doing that, and it's come kind of behind on that. Let's see, and then some Python projects. The master's that I'm in is not heavy on Python in the way that I would like it to be for data science. The data wrangling class is more so, but so sentiment analysis with Twitter, we just basically use their API, and then text analysis, integer programming. There's some other stuff. Yeah, I don't know. Yeah, so now I'm basically deciding on what I'm going to focus on, if I'm going to go more towards deep learning, reinforcement learning, or stick with machine learning, or just be more broad spectrum with artificial intelligence. And then also, do I want to focus on sensors, embedded systems, or in the human in the loop research? And I don't know, should I do like questions or something? As it's obvious I'm not really a public speaker, though. And then I guess some of this stuff, if you guys are really heavy R coders, have mercy on me. I'm probably going to look back and be like, oh my gosh, that was a horrible, I don't know, mistake that I made in that project or something. But I think my teacher gave me a good grade, so I guess I'll count on that. Okay. All right, do I need
we have time for
questions later?
Questions for Brittany?
Okay.
I guess I would ask, like, looking, now that you're in the midst of this program, do you have any lessons learned or advice for students who are starting a master's in data science? Yes, hardware is very important. So I have this 2011 MacBook that I dropped a terabyte solid state drive in, upgraded by RAM. It's like, yes, okay, I'm ready for this. And then it has an i5 CPU, and that just like, and so I ended up getting better, desktop system. So I guess, yeah, hardware is a big thing, especially if you're building out clusters, if you're building out nodes with Hadoop, that's going to take a lot.
Are there particular kinds of problems or things you're interested in, like in sort of applying all this new knowledge to?
Mm-hmm. So yeah, that's what I'm kind of like, I'm trying to narrow, I guess it's really broad, and I'm trying to narrow in more. I'm actually taking a class right now where I have to do research on a particular problem, and I'm in the midst of developing that now, and hopefully that will lead to kind of more of a focused trajectory.
Well, you mentioned the website and the contact information.
Mm-hmm. Oh, okay. So ways you can get in contact with me. So this is my website. That's my LinkedIn, phone number, email address.
You need to leave that up. There was a question in the back, behind you, Chuck.
I just was curious how you called it, I think you're doing some side work or something like that. Does that blend in with your master's program?
So I'm a field researcher for the University of Michigan. I'm in the production role. It's basically like data collection. It's not really data science. I'm not, doing any sort of analysis of the data. I'm just making sure it's nice and pretty for the most part.
Last question that was in the hat. Yes.
Oh, yeah. So the website you're describing, is that what you've been showing
Yes, yeah, that's my personal website. It's also my way of like kind of tracking the work that I've done so far because it's kind of it's easy to get, I don't know, lost in the shuffle.
Well, it's incredibly impressive.
Oh, thank you. Yeah, I have to like limit the amount of time I spend on it. You're like, oh, I like that color, maybe this one, and it's like that's meaningless. It's just color.
Let's thank Brittani again.
Thanks.
Okay, hello. So I am coming at this lightning talk as a data user, more so than a trained and true data scientist, though I think I've become one over the years. So I'm an assistant professor in climate and space sciences and engineering, so up in the College of Engineering. I actually started with my bachelor's in geosciences, so I was in caves collecting drip water and looking at paleoclimate applications. But I did my PhD at University of California, Irvine, essentially in data science, I wish, atmospheric science. So that's actually where I learned how to program. So starting with MATLAB, and now I primarily use Python for a lot of my work. You know, I think the thing I want you to get away from this is the sheer amount of data available. So this is a satellite image from a geostationary satellite showing Earth. And so I wanted to start with what does Earth science data actually look like? So this is going to be focused on the atmosphere more so than the ocean. Sorry for the oceanographer. You know, let's just start with observation. So you have, can't walk too far. You have satellite imagery. So we have this geostationary satellite goes east. Cygnus is the Cyclone Global Navigation Satellite System. So this is actually something that is connected with my department. So Chris Ruff, if anyone knows that, is a PI on this project. And then you can also have field campaigns. So this C-130 atmospheric river reconnaissance project. So this is more applied to what I actually look like, or look at. Sorry. And I wish I could be a part of this because it looks really cool. But I know the people in charge of this project, and so they basically fly these airplanes and transect this atmospheric feature and drop basically instruments out of the back of this airplane and measure the vertical profile of the atmosphere. And then you also have basically data that comes from an observational station that is kind of in place. And so this is one example from the middle of Oklahoma, the atmospheric radiation measurement facility, and this is actually data that I use for model evaluation, as I'll show you later. And so that's all the kind of observations. So what you see in the top left corner is a snapshot of all of the observations that one particular data assimilation model takes to create a kind of a gridded product for people like me to use. And it's not very visible right now, but basically this map is covered in dots. And so each of those dots represents a different type of observation. So these vary in basically the time step between each observation. They vary in the spatial resolution. So data assimilation is actually a field in itself. Not one that I'm very familiar with, so hold off on the questions there. But what happens is you basically you can take observations, raw observations or processed observations, and put them into a model and basically get modeled data. And so there's a number of things that kind of build up these models, and at the most fundamental level, you start with kind of these governing equations, so momentum equations, conservation, so on and so forth. But there's a number of things that can introduce uncertainty. So, the resolution, we're talking about spatial temporal resolution. The domain, are you looking at a global scale? Are you using a global scale model? Or are you looking at, say, for example, Texas, and that's it? Initial and boundary conditions. So how do you actually start the model running? Okay, so there's another source of uncertainty. Parameterizations, I'll talk about in the next slide a little bit more, but these are basically things that we can use to estimate things that are happening below the grid scale. And then finally, numerical approximation. So you need to do some rounding somewhere. That's a very broad way of saying that. And then you get these very nice figures, like one I made. And I'll talk about this feature in a little bit more later. This is a really nice schematic showing what actually goes into a general circulation model. So you can see you have basically grids covering the Earth, and then you also have vertical levels. So in the atmospheric sciences, we usually think about vertical levels in terms of pressure, but the model might not actually use that. So the grid scale defines the resolution of the model. Smaller the grid cells, the more detail in the model, but then that's where you run into computational limitations. So I can't run models on this computer. I actually have to use a supercomputer, which happens to be located in Wisconsin. And sometimes crashes, which is not great. And so you can see within these grid cells, the typical size is around 100 kilometers. There's a number of processes that are basically estimated within these grid cells. So yes, so getting into what I do, and this is a very brief snapshot of a small portion of my research. So one of the things that I focus on is model evaluation. So there are these features that are not well captured in GCMs because of essentially their generation mechanism. So they start at, basically thunderstorm scale, so very small, and then they bloom up to these massive, basically state-size storms sometimes, if you're looking at a smaller state. So these are mesoscale convective systems. They are responsible for up to 70% of summertime rainfall over the Great Plains. And so essentially to model these, you need to get to very high spatial resolutions to start to get at resolving potentially some of the convection within the model. Now you run into computational limitations. So while we wait for the computer sciences to catch up, this is kind of the cutting edge for GCMs, so variable resolution models. So we have a uniform grid, and what we're doing is we're comparing that to a grid that is refined over a certain region. And so the questions here are, how well do variable resolution models actually capture these multi-scale features? And then what is the effect of these parameterizations or the estimations in the development of these features? And so I have some work on this, but because of time, I'm going to skip to the next. So the other thing that I'm very focused on and is consuming a lot of time is actually feature detection. So I am very interested in how atmospheric rivers, what modifies their behavior at the large scale. So large scale circulation, how does that modify these very narrow pathways of intense horizontal moisture transport in the lower atmosphere? I should have defined it. And so I've circled what that looks like in my nice little globe that I plotted up there. And these are really important because they are tied to a lot of flooding events, mudslides, oh no, 1 minute, flooding, mudslides, and the like around the world, but mostly in California. And they're also essential to water resources. So the definition right now is largely qualitative. So you look at this and you're like, oh, that's an atmospheric river. So that's basically led to a lot of quantitative ways of looking at these at the climate scale, so beyond the event by event basis. Some questions here, but I wanted to leave you with this. This is showing the diversity of algorithms to actually identify these features. There are a lot there, and so I am a lead author on a intercomparison project to start to quantify the uncertainty in the choice of algorithm in atmospheric river science. And this is just showing a single atmospheric river and all of these different algorithms identifying some portion of this feature. So what precipitation is associated with these features, how are they going to respond in a changing climate, so on and so forth. These are questions that we're interested in. So thanks.
One quick question, if there are any.
Yes.
So those atmospheric rivers, like, are they permanent like a regular land river, or do they move?
They're transient, so they move, and that's one of the difficulties about detecting them. Yeah.
Are there like jet streams?
So they occur much lower in the atmosphere than jet streams, but yeah, you can think of them as yeah, corridors of high winds in the lower atmosphere.
With that, let's thank Ashley again.
So hi, everyone. My name is Rose Putler. Today, I'll be talking about the ABCs of career confidence, which is, while I am a data scientist, this is sort of tangential to that. Since I don't have that much time, it's really going to be the abbreviated ABCs of career confidence. So a little bit about me. So I have a couple of different degrees in statistics. So an undergrad in statistics, a master's in biostats. I have what I think is some respectable job experience managing projects, managing people, working at the medical school. I currently work at Thermo Fisher Scientific, and I will not talk about that at all. But if you have questions about it later, feel free to come talk to me. But I'm now sort of a bioinformatics scientist. Yet I still don't feel that comfortable calling myself a statistician or an expert in any way sometimes. So you may be sort of wondering why I'm, oh my gosh, my slideshow, why I'm talking about career confidence. So do I have confidence in my career all the time? No, I don't. And the confidence I do have, I feel like, is hard won. But based on some conversations I've had recently with students and folks who are looking for jobs or who are transitioning careers, I think that I have some insight, and I want to share that insight with you. So I'm going to talk about the abridged ABCDEF. I'm not getting any further than that. ABCs of career confidence. So A, advocate for yourself. So one of the things that I think I have realized over time is that you shouldn't assume that anyone knows what you're doing. You are your biggest champion, and no one's going to sort of know what you've been up to or why you're awesome or why you're invaluable unless you really sort of talk about it and bring it up. And the first step to doing that is really tracking it. So something that I do is once a month, I try to rack my brain and say, what cool thing did I do this month? Even if I can't really come up with anything that feels important, I try to track it, because that way I can look back in 6 months and be like, oh yeah, I did that cool thing. So things to think about. What ways have you been awesome recently? What is it that you want from your career? What's your trajectory? Tell your boss, tell your friends, tell your coworkers, and track it. But no one else is going to do it for you necessarily. So it's scary, but it's important. B, be everywhere. So congratulations, first step, you're here, you made it. You're networking, you're doing things. And that's really I think important. So go network, go talk to people, your coworkers, other people. Even if it seems lame, even if you're not sure you should go, if you don't belong, even if you're the intern or the student, you should go, you should meet people, you should be networking. Over time, you will really start to feel more confident and start to feel like, oh wait, I actually belong here, people want me here, I am contributing. C, now this one's gonna make everyone upset. Cover letters matter, and I'm sorry. I hate cover letters, you hate cover letters, we all hate cover letters. But I would argue that they're not just important for the job you want, the job you're applying for, they're more important for you. So what you're doing is you're giving yourself the time and the space to sit back and say, what do I like about this? What do I like about what I'm doing now, what I'm doing in the future? They allow you to sort of sit back, think about what you want, and then actually express it, which are two very different things, especially when you're like in the midst of applying to 18 jobs and you hate them all and you just want a job. So give yourself the time and space to really write a new cover letter. Understanding and conveying sort of how you fit and why you like it will help you stand out, not just in that cover letter and get you the interview, but then in the interview you'll actually be able to say, hey, I know why I want this job, and articulate that. So, and this is another thing you'll hate. Don't recycle cover letters. Really, don't do it. D, a little bit different, doubt others, but not in a mean way. So what I mean with this is you may think you don't know what you're talking about, and that guy does. They don't, I promise. Everyone is faking it. Not everyone knows what they're talking about, at least not all the time. And by doubting nicely, being skeptical, paying attention, asking questions, you may catch something that other people didn't think of. You may have that insight, that out-of-the-box thinking, where you can say, hey, what about this thing? And if worse comes to worse, you will get credit for asking the question, for paying attention, and really you have nothing to lose to just make sure you're sort of doubting, which sounds, I mean, we like our coworkers, right? We think they're smart people, but doubt them in a nice way. So, E, elevator story. Now, I hate the concept of an elevator story. I think it's like very strange, like, why am I talking to someone in the elevator? Why am I telling them about what I'm doing? Why do they care? I just want to get off on my floor. So I think there's a couple better ways to think about this, and I'm going to go over one of them in detail, and I took out one of my other slides, but that's fine. So the first way to think about it, the only way I will talk in depth about right now, think of someone you love, who loves you unconditionally, but has absolutely no idea what you do. Doesn't know. Absolutely not. They're not in the field. They have very different skills. So rather than an elevator story, and I have permission for this one, I'm going to call this an Eric story. So this is my fiance, Eric. He's wonderful. He's great. He has a degree in philosophy and thinks that what I do at work every day is sort of like bloop, blop, bloop. He has no idea what I do at all. And so if I want to simplify what I do, if I want to think about how I talk about what I do every day or in an abstract way, I think about how would I explain to Eric or sub in another person? How would I explain to them? How would I simplify it? How would I sort of take its parts and explain it simply? So I sort of try it out on him or just pretend that I'm talking to him. So how would you describe your interests or your job to someone who wouldn't judge you? So you shouldn't have sort of that fear. You should have the confidence when talking about it, but has no idea what you're doing. Because I think it's easy for us to say, well, everyone knows that. And what I'm doing is not that special. But it is. It really is. You do know things. That was another option for D. And then if you're trying to sort of talk to other people, I lost the elevator story there. Sort of just think about how can you talk about your jobs, your interests, and sort of frame it in a way that helps you feel confident. If it helps to think about someone a little more technical, you can sort of build off that simple story to start with. So last but not least, F, forge ahead. You won't always feel confident. Month by month, week by week, second by second. You may have high and low times. Sometimes you'll feel really bad. So my other F, feel your feelings. So try to understand why you're feeling the way you're feeling in a professional setting even. So in my last 3 years, I've worked at 3 different jobs, and each time I've enjoyed it more because I really took the time to understand why I'm feeling the way I'm feeling from a positive and a negative standpoint. This will allow you to actually make that next step, move forward with confidence. So listen to your feelings, whether in the current job, in the future one, but generally this will allow you to sort of build resilience, become more confident, and move forward in your career and in your work. So thank you. These are my ABCDEF of career confidence. Tangential data science, but I can also talk about what I do at some other time afterwards. So thanks.
A couple of questions.
So for the elevator story, do you recommend that you never use jargon, even if you're like at a professional conference?
I think that's fine. I think I sort of try to feel it out. So one of my other things, one of my side that I didn't include is a friend of mine named Eve. I know a lot of people with E names who has like a technical, she has a PhD in a technical field, and I'm always trying to impress her a little bit. And so part of that is thinking about, okay, you start at that simple story, and then you say, okay, how do I sort of talk about it in a way that sort of ups the technical factor, ups the jargony factor, especially if you're in a conference setting and you're like, I'm gonna impress this guy, you know, like sort of thinking about it in those 2 different ways sort of has helped me sort of crystallize and then embellish upon it, if that makes sense. So I think jargon is fine, but in the right time and place.
How do you, what's the best ways to get out of an echo chamber? Especially if you're in academia, you just tend to interact with only academic people. How do you kind of break free from that?
I mean, for me, it has involved, and I didn't mention this during the cover letter stuff, but when you're sort of thinking about and talking about sort of bringing in outside voices who are not in the same area, and part of that might be meeting someone here and saying like, oh, hey, you know, I'm interested in what you do, or it sounds like you have an interesting experience, and having that conversation. I think sort of getting to both questions in some way, like as you're writing cover letters or talking about what you're doing, sort of having outside editors on some level, right, can help you both network with someone who's outside your field or outside academia or outside something, but also give you some clarity so you're not just sort of like stuck in the jargon or stuck in the, I don't know, the headspace that everyone knows what I know. I don't have anything interesting to say. So I don't know if that answers your question, but.
Anybody else? All right, let's thank Rosie.
Hi, my name is Laura Burdick. I am a PhD student in computer science and engineering at the University of Michigan. I just finished my 4th year in my PhD, and I'm going to talk to you a little bit about some of what I've been working on recently in multilingual data. So to start, I should explain that I do research in natural language processing. So lesson number 1 is thinking about what is a word in different languages. And this was something that I was not expecting necessarily. I probably should have been, but I wasn't, and so this was something I learned. So this is a sign in 3 different languages. The English translation is on the top here. And then we have Romanian, Hungarian, German, and so this is just some administrative sign. What's really interesting here, though, and what I want to draw your attention to, is how many words each sign uses. So the sign says the exact same thing in all of these different languages. But note that Hungarian is able to say this exact same thing in 5 words, whereas English, the English translation takes 14 words to say the same thing. That's a pretty huge difference for a small sign. And so this is clearly indicating that the idea of a word is changing language to language. Some things are certainly the same, but the amount of meaning that a word is capturing is certainly changing across languages, as demonstrated here. So here's another example. Oh, I hope you can read this. Basically, this is Turkish words here on the left and their English translations on the right. And you can see Turkish is what's called an agglutinative language. And so this means you can basically make words by taking tiny units of meaning and stringing them together. And so you have this ability to create very, very long words with very specific meanings. And we don't do this nearly as much in English. I mean, you'll find a couple of examples, but not nearly as much. And so you kind of have that ability in Turkish. All right, so bringing this back to kind of data science and data analysis, what are you supposed to do with this if you want to work with multiple languages, but you have this disconnect of words are different in different languages and you can't compare them apples to apples necessarily? So here's our example. If we have the clause watching the runner go by, I would say there's kind of three different options. You can work with things at a word level, recognizing that at a word level the words mean different things, but still I think sometimes it makes sense to work with them at a word level. You can go to the most granular level and think about things at a character level. I would say the caveat with this is that not all languages are written in a Latin script the same way English is, and so the set of characters is not even going to be the same across languages. There's also kind of an intriguing middle option, which I think is cool, and that's the subword level. So somewhere in between the word level and the character level. So maybe you take the word watching, and you break it down into watch and ing, and those kind of have some meaning in themselves, like the root and the suffix. And there are different, here are a couple citations for things you can do with subword units. There are lots of other methods you can do with subword units. So which of these are you supposed to use? I would say the answer is it really depends on what you're trying to do, but it's something that you have to really be aware of and think about when you're working with multilingual data. Okay, lesson 1 was on word variation. Lesson 2 is on language variation, and this in some sense is an extension of lesson 1. So if lesson 1 is that words are going to vary dramatically language to language, let's go one step farther, and I will just say languages vary dramatically on pretty much every parameter that you can think of. And so when you're working with multilingual data, this is going to really affect your analysis. So there's a couple of websites that are really nice for gaining insight into this. I'm not going to talk too much about it because it's like a whole field of study in and of itself, but I'll just throw these out. Ethnologue catalogs all the living languages of the world. So here's the page for English. You can learn lots of useful facts about English and any other language you want to know about. I've worked a lot with WALS, which is the World Atlas of Language Structure on, this is the online version. That's not in the acronym. This is really cool because it takes properties of language. So one we're going to look at here is subject, object, verb order. And then it assigns every single language a value. And so you basically can download this whole table of values for all of these different languages on all of these different properties, and that's really fun. And that can help you. So here's for an example. They have cool maps and stuff too, which are less useful for data analysis, but fun to look at. So these are ancient languages, and this is subject, object, verb order. So if I say, John eats a cookie, John is the subject, eats is the verb, a cookie is the object. So in English, right, that's the subject, verb, object, SVO. But not all languages order them in that order. So different languages will do different things. They'll put the verb first. They'll put different things first, and so that's a difference. Anyways, I'm going to leave it at that, but I'm just going to say that language varies a lot, and that can mess up your processing. And so it's worth being aware of this and recognizing how this affects your processing. Okay, last lesson is that when you are using pre-built tools, I'm particularly going to focus here on natural language processing tools. 1, they are not available in all languages, and that is its own story. 2, they do not work equally well in all languages. So you cannot just assume that something out of the package that works really nicely on English is going to work really nicely on the language you care about. And I want to talk really briefly here about word embeddings, which is what my dissertation research is around. For those of you who don't know what a word embedding is, it's basically a way of representing a word in a computer. So it's a vector representation of a word. You can kind of think about it like a point in 300-dimensional space. And these are like much simplified, so this is like dumbed down to 2 dimensions, so I can like draw it on a slide. But here are points for these different words, and they capture some of the meaning of the word. So they capture the usage of the word, or the part of speech of the word, or other different properties of the word. So there are different ways that you can measure kind of the quality of a word embedding. One that I have done some work on is this definition called stability. And this kind of means if you take 2 embedding spaces, like from the same data, and you look at the nearest neighbors for a word. So here's our 2 embedding spaces. These are all like points, right, in 300-dimensional space. We're taking the same word, international, in both languages, and we're looking at its 10 nearest neighbors in 300-dimensional space using like cosine similarity or some other like similarity function. The stability is how many of these neighbors overlap. So in this example, 4 out of the 10 neighbors are the same. So we're going to have 40% stability. So this is sort of a way to measure the quality of the word embedding. Maybe consistency is like a better word. You can kind of think about this as like a way to measure consistency. So one way to think about this is, what if you had the same word embedding algorithm in the same data, but you ran it twice with like 2 different random seeds, or something like that, or on 2 different subsets of the data, like some kind of trivial change that you think like shouldn't really affect the structure. How consistent is your word embedding across that? And this is a way to sort of measure that. I'm happy to take questions about this at the end if that didn't make sense. So, but I will just say this is kind of a metric of quality. So if that went over your head, this is a metric of quality, leave it at that. And some of the research we've been doing recently suggests that the quality is very, very different for different languages. So looking at our set of 38 languages, we found that Vietnamese is the most stable, and it kind of has an average stability of 23%, jumping all the way down to Lithuanian at about 6%, and then English, just for sort of a reference point, is around like 8%. Which brings us back to the point that not all tools work equally well in all languages, and that's something to be aware of when processing multilingual data. Feel free to get in touch with me. Thanks. Questions?
Yeah, so I don't fully understand stability, but does it mean like the words kind of mean the same thing, like they have a similar meaning like across different languages, or?
Yeah, so it is kind of a sense of like the embedding is capturing the same thing. So you normally don't do stability across different languages. Just languages are so variable that it'd be hard to get that to work methodologically sound. So normally this is like these numbers right here. This is stability within a language. So we're not going across languages, we're going within languages. So we're looking at just embeddings in Vietnamese, how good are they? Versus embeddings in only Lithuanian, how good are they? Not necessarily like going across language. But within a language, it is a sense for like, if we had kind of 2 Vietnamese embedding spaces on the same data with the same algorithm, like, are they consistent? Like, do they have the same nearest neighbors? Are they capturing like the same structure? Does that help?
Yeah.
Okay.
So you mentioned that there's different ways to tokenize. There's different ways to find the words in the languages. How did you compare, say, like the equative? Did you go with the subword, the morpheme?
So for these right here, so this is somewhat work in progress. For the results right here, this is just like word segmentation. It's the OpenNLP probabilistic word segmenter for when that's available, and if it's not, it's like it's called the Unicode. It's like a Lucene algorithm, and it's kind of based on like Unicode. I'm actually really interested in the subword stuff, and I think the next set of experiments will be using something called sentence piece, P-I-E-C-E. But also, and that's kind of something that's been pretty heavily used in like machine translation for solving this exact same problem. Yeah.
We'll take one more question. There was somebody in the back left next to the TV. Yeah. Yes.
Oh,
Back to the embedding question for the different samples, do you mean like something like from the same book, like different pages?
Yeah, that's a good way of doing it. So in this experiment, perhaps I should have given a little more detail about that. Sorry if that was unclear. We used Wikipedia, and we took Wikipedia in all these languages, and then we downsampled Wikipedia, because so the Wikipedias are all very different sizes across different languages. So we downsampled Wikipedia to make it the same size across all the languages, but we did multiple downsamples. So we like selected 5,000 sentences from Vietnamese once, and then we selected another 5,000 sentences, and now we've got 2 same size sets of Vietnamese Wikipedia. We can train 2 embedding spaces on that, and then we can compare them in Vietnamese. Kinda.
We'll
Okay, come talk to me later if you still have questions about it. I'm happy to explain it more.
Hopefully everybody here today not only learned a lot from all of our speakers, but also possibly be inspired to take part in our future lightning talks, right? So let's thank not only Laura, but as well